sent in by Pamela Bartlett of Danvers, Massachusetts. Strange things happen during a full moon.
Well, when the full moon comes out, are there higher crime rates, birth rates, and suicides? We've all heard those myths, but are they fact or fiction?
Certainly seems so, but is it true?
It's a full moon, and that means chaos for emergency service workers. For centuries, there's been talk of how the full moon affects how people behave.
It's a loaded topic the skeptics say is nothing more than superstition.
It's a myth.
The scientists can say what they like it doesn't affect them, but I know that when there's a full moon, there's definitely going to be an increase of patients.
It was news that made headlines around the world.
It's called the supermoon, a term coined by Richard Noley for when the moon's orbit is nearest the Earth and the sun, moon, and Earth are all in alignment. That means the gravitational pulls of the moon and sun combine to cause higher tides.
And Cyclone Tracy laid waste to Australia during the supermoon year of 1974. There were also extreme weather events in the supermoon years of 1955 and 1992. However, most astronomers say this is just coincidence.
To get us started off, I have Tristan Schwartz, who is a member of the Colorado Springs Astronomical Society, very involved with them. He's also an amateur astronomer and a science writer, and he'll get us started with some common moon myths.
Everybody, I want you to shoot for the moon. Shoot again. If you miss, shoot again, keep shooting and never stop. Someday one of us will destroy that stupid sky circle and... Wait. It's right behind me, isn't it? Shit, everyone act casual. In my time of doing astronomy outreach work over the last several years, currently with the Colorado Springs Astronomical Society, previously with the Arizona Museum of Natural History, I have come across a lot of really strange ideas that people have about the moon, and a lot of very deeply held beliefs about those ideas. And unfortunately, most of them are wrong. Most of the ideas that the general public has about space and astronomy and science in general are unfortunately wrong. Our schools really fail at teaching science. But also, when you look at those myths, at those ideas that people have, ultimately it tells us a lot more about people than it does about the moon. And we're going to start with one of the most, as in those news reports, one of the most commonly held ideas that people have about the moon is that the moon affects human behavior. Go on to the next slide. You've heard this phrase before, more times than you can count, probably. The thing is, nobody can adequately say the mechanism by which the moon affects people's behavior. And it really doesn't. When you actually plot out the data of hospital admissions, birth rates, or conception rates, I should say, mental health professional incident reports, et cetera, violent crime, et cetera, et cetera, et cetera. You don't see, over a course of a month, and from month to month to month, you don't see peaks in the data with the full moon. And there have been, at the time of that interview with Michael Shermer, the number of studies was at 37. At present time, it's closer to 60. There have been about 60 extensive studies published in Nature, in Psychology, all the major journals that study these sorts of things. And not just little rinky-dink small sample size studies either. I mean, we're examining nationwide crime rates, and you just don't see those peaks that you would expect to. It doesn't happen. But if you talk to mental health professionals, law enforcement professionals, hospital or emergency room workers, you get the impression that this is something that they batten down the hatches and they prepare for. So where is this disconnect between what is observed by the people on the ground and what the data actually says? Next slide. Well, it turns out this is a fairly common thing. Everybody has a tendency to remember things that support their beliefs and kind of disregard everything else. So did you read the paper on confirmation bias? Yes, but it only proved what I already knew. It's called confirmation bias. And basically you're more likely to remember the data points that support what you already believe. Strange things happen all month long, and I have friends in law enforcement, I have friends who work in emergency rooms who don't believe in the moon effect, don't report a moon effect. Strange things are happening all month long, but the people who believe in the lunar effect are more likely to remember the incidents that happened at the full moon and disregard everything else because those don't support the belief. It's really common, but again, it says more about us. It says more about people and our logical fallacies and our biases than it does about the moon. Now, here's another idea that has come up that I would have thought was an old wives' tale that's kind of disappeared, but it's still out there. It's still really strong. And it's that the moon, the lunar cycle, controls the human menstrual cycle. It comes up a lot when I'm doing astronomy outreach events, and I thought it was something that people had stopped believing in, but a few years ago, I think it was 2009, I was organizing an astronomy outreach event at the Arizona Museum of Natural History, and a woman came up to me and asked me about this. Specifically, she wanted to know the exact mechanism by which the moon affects the menstrual cycle. She was assuming it was tides. She didn't know. And I said, well, it doesn't, but I will never forget what she said next. Go ahead to the next slide. She said, "It must be true. I saw Peter Gabriel say it in a concert film once." Now, to be perfectly fair, I own that same concert film on DVD. It's a great concert film, but Peter Gabriel ought to stick to mind-shattering progressive rock and not dispense scientific advice about how hoo-haws work, because, yeah. That, again, also says something about people. If somebody is in a position of authority, they're assumed to know something more than everybody else does, then you're more likely to listen to them even if they're speaking outside of their area of expertise. This is called argument from authority. Somebody who is famous seems to know something about it, so it must be true. That's why Jenny McCarthy is so popular in immunology circles right now. But it kind of brings up another logical fallacy that people have. Argument from authority. Just because somebody says it that I perceive to be important, it must be true. What is the actual thing going on here? Well, the human menstrual cycle is on average 28 days long. The lunar cycle is approximately 28 days long. So the assumption is that one must be regulating or causing the other. Well, here's how science works. You start with an idea, and then you extrapolate from that idea and say, okay, well, if that's true, then this must be true, this must be true, and this must be true. If the moon was regulating the menstrual cycle, then there's a few things that could be expected as a result. A, that that period wouldn't change, that interval of time would never change. B, that every woman would get their period at the exact same time. That's not what happens. The 28 days is just an average. You can see changes in it from stress, from medications, from changes in diet, from changes in amount of physical activity. And also, it happens at different times of month for everybody. So clearly that has failed the test of science right there. And that's how science works. If something fails that test of extrapolation and then explanation, then that idea is discarded. But this idea is tenacious, and the reason being is that 28 days here, 28 days there is something that's hard for people to let go of. And that's another fallacy called the correlation causation fallacy. And you see this a lot in reading the news every day. Whenever there's a news article about medical science or about a food being tied to say cancer, for example. You see it all the time. People automatically assume, news outlets automatically assume that because you see an increase in one thing and an increase in this thing, one must be causing the other. One of my favorite examples of this that's used in classrooms a lot has to do with ice cream. If you plot the amount of ice cream consumed in a given month versus a certain other thing, you see a stark correlation. Violent crime. There is a huge increase or huge correlation between ice cream consumption and violent crime rates. So, does eating ice cream make people violent? Or does murdering your entire family give you a mean craving for Rocky Road? No, is actually a third factor at work, and that is hot weather. But if you only look at two of the data points, you're missing the big picture. This comes down to the fact that the human brain is really, really good at pattern recognition, but this also gets us into trouble because we frequently recognize patterns that aren't really there. We see a seeming correlation between the 28-day period of the lunar cycle, the 28-day period of the menstrual cycle, and we make assumptions because we think we see a pattern there. But we also often see patterns that don't actually exist. And that's still part of that same fallacy, is that people expect there to be patterns. They expect there to be simple cause and effect, and the reality is the world's a lot more complicated than that. I found this cartoon that really kind of illustrated it really well. Everybody who went to the moon has eaten chicken. Good grief, chicken makes you go to the moon. And now this is the one that's been really sticking in my craw lately, and I've been getting so many questions about this when doing outreach events with the public, and that's the supermoon. You can't turn on the news without hearing something about the supermoon whenever there's one approaching, and I'm going to use quotation marks whenever I say supermoon from here on out because it's the dumbest thing. The correct term actually is much more fun to say, perigee syzygy. But the term supermoon comes from an astrologer who coined the term in 1979, so that immediately just makes me angry. But a lot of people assume that this is a new phenomenon, and that's the thing I hear time and time again. I've gotten at least 3 questions about this at each outreach event I've done over the last year. Why are we seeing so many supermoons suddenly? It's nothing new. They've been happening a couple of times a year for, ever, since there was a moon. And it's been a well-understood phenomenon since the time of Kepler, since somebody first figured out how orbits work. So this isn't anything new, but a lot of people are scared of it because it's something that, because the media makes a big deal out of it. And the media has tied it to hurricanes and earthquakes and volcanoes. And I saw one report that actually said it had something to do with global warming. It scares people. Media are the biggest attention whores on the planet. It's not just the tabloids. I've seen stuff about supermoons causing catastrophes on CNN, NBC, CBS. All the major media outlets are jumping on this bandwagon, and people think that the supermoon is something new, and it's not. It's been happening with the exact same frequency since the moon existed. So my message for everybody is just don't panic, because we're not going to have a magnitude 23 earthquake that's going to split the Earth in half next time there's a perigee syzygy. What actually is a supermoon or a perigee syzygy? Basically, what Kepler discovered is that orbits are not circular. They are elliptical, they're elongated, they're egg-shaped. Or two-dimensional egg-shaped, I should say. Like any orbit, the orbit of the moon around the Earth precesses. So it kind of ultimately makes a shape like this is exaggerated. But as it goes in the ellipse, at some points during that orbit, it's going to be in one spot at its furthest point in relation to the Earth, and at a different spot in its furthest point in relation to the Earth at a different time. As a result, sometimes these orbits line up, sometimes in just the right way, so that when it's at full moon, it's at its point where it's closest to the Earth, and it appears somewhat larger, somewhat being the operative term here. Likewise, if it's at its furthest point, or an apogee syzygy, when it's at full moon, it's going to look smaller than average. And these also apply to new moon, and I'll get to that in a second, but it's really not that dramatic. And then people make a bit, news reports make a big deal about it's being X% bigger and X% brighter, but is that really visible? Just how super is the supermoon? Well, turns out not very much. This is a supermoon and a mini-moon, basically a perigee syzygy and an apogee syzygy when it's at its furthest point during full moon. And that looks kind of like a pretty big difference right there. But when you're actually seeing it in the sky, the human eye and the human brain are pretty bad at determining just how big something is. And sometimes the moon will seem to look pretty big, but on average, the moon doesn't look any bigger than a dime held at arm's length. And so this difference is about the difference between a dime and a penny held at arm's length. Not a very big difference. And we're not very good at gauging the size of objects in the sky. That's partly why the moon looks bigger when it's close to the horizon, because you're seeing it in relation to other objects. But when it's up in the sky and there's nothing around, it looks lost in a void, basically. And here's a comparison between a supermoon and how big it is on average. That is a tiny, tiny difference, and especially when you're talking about something the size of a dime held at arm's length, in terms of its what's called angular size, you're not going to be able to see that difference between an average full moon and a supermoon with the human eye, especially when the human eye and brain are particularly bad at gauging how things are. So, just not enough of a difference to be visible and noticeable from month to month. So a lot of people go outside to see the supermoon, they're kind of like, well, that's it. Or they get really, really excited and they're convinced that it's like filling the entire sky, and it's all just basically in your head at that point. But again, it's hyping people up to see something. They're expecting to see something a lot more spectacular than they actually wind up seeing, and that's bad for astronomy and for interest in astronomy, because if you get people, hyped up and it fails to meet their expectations, then you're going to turn people off from science, and I don't like seeing that happen. But that's not to say that fascinating things can't happen with syzygies. For example, when you have an apogee syzygy at new moon that also lines up with a solar eclipse, then you can get an annular eclipse or a ring of fire eclipse. 2 years ago, my dad and I drove down to Albuquerque to see one, and I took this montage of pictures, and it was one of the most beautiful things I've ever seen. So syzygies can still be exciting, they can still be fun, but just if the media leaves it alone and doesn't overblow the wrong ones. This talk so far has been fairly disappointing. All this cool stuff about the moon turns out to be, well, a whole bunch of BS. But the moon is far from boring. And to close, I would like to tell you what science has actually revealed about the moon. By studying the moon, and by studying its composition, and by studying its orbit and the way it's slowly moving away from the Earth, we figured out a few really interesting things about it. About 4 billion years ago, the solar system was a very, very different place than it is today. Much more chaotic and many more planets. But we don't see as many planets today because in the process of forming the planets that we see now, many of these smaller planets were absorbed into larger planets. Some of them were smacked to pieces. Some of them may have even been ejected from the solar system by their orbital interactions with other planets and have become rogue planets moving through the galaxy, untethered to a star. But we know of one of these planets that was the size of Mars, and about 4 billion years ago, it collided with the Earth. And it probably looked something like this. This is an artist's conception. We don't actually have photographs from when it happened. This was two enormous planets colliding and then spreading out a huge debris field that formed around the Earth in a ring called an accretion disk. And over time, that condensed as bits and pieces of the material thrown off from that collision slowly coalesced by gravity and formed the moon. The moon is the byproduct of planets colliding. So when you look at how all these things we believe about the moon turn out to be, flat out bunk, but the reality is far more dramatic. And I'd like to close with this quote from Phil Plait: "The universe is cool enough without having to make up crap about it." Thank you.